All right, welcome back to Blackburn Defense. Today we're starting a new series on why doesn't every bullet go through the same hole. This is a 300 grain Sierra Match King, and let's say you take 5 of them and you shoot them at a target. For some reason, even for the best shooters, every bullet doesn't go through the exact same hole. Let's talk about why. All right, let's grab one of these bullets over here. And let's take it and stick it in the lathe, cut it in half, and see what it looks like inside. So we're going to take it, I'm going to chuck this up. And we want to go tight, but not too tight, because we don't want to deform it too much. Well, always remember, spectacles. All right, there we go. Got my parting tool in there. Got through the hard part, now the easy part. All right, so we cut this thing in half. What can we learn from this? If I zoom in on this, I'm going to find in the middle is a lead core surrounded by a copper jacket. But what if we want to inspect only the copper jacket? We got to cut up another bullet. So let's get back to the lathe. Put my safety glasses back on. Now this time is going to be a little different. Make sure that's in there secure. I'm going to come in and I'm going to go and cut. You're going to see that it's cutting that copper jacket. It doesn't like it at all. Oh, we got through the copper jacket. We're to the lead core. So I'm going to back out. And then I'm going to grab these high precision pliers. And I'm going to just yank on this sucker. Oh! And look at that. A beautiful lead core. And if I open this up, look at that, a nice jacket. Let's inspect this jacket. Let's grab our handy dandy ball micrometer. This is a neat tool that lets us measure wall thickness to within 1/10,000th of an inch. And you're gonna see as I spin this jacket on here, we're gonna get slightly different readings all around it. I'm going to exaggerate that thickness for illustration purposes, and we're going to find that one side is a little bit thicker than the other side. And when I say a little, I mean 0.0003 inches. To help illustrate how small that is, I pulled out a hair from my head, and I'm going to go ahead and measure that. And we're going to see it's 0.003 inches across. So if you cut this 10 ways, that represents how much air is in the seem like much, but these bullets are spinning at 200,000 rotations per minute. Imagine you take a top and spin it. When it first touches down, it kind of goes off in a random direction until it finds its center. The bullets kind of do the same thing. When it's heavier on this side, it might kind of go off in this direction. All right, let me grab one of my favorite barrels of all time. It's actually shot a lot of these bullets. And imagine this bullet's like a top, where when it comes out of this barrel, say the heavy side of the bullet is on top, it might make it spin up and away from the target. But if it's on the left, it might make it spin left and away from the target, or right and away from the target. The point is that you can't predict which is the heavy side of the bullet and its orientation when it leaves. So you get a random direction of dispersion. And so that's why you might not get every bullet going through the same hole. Now, let's look at an equation that describes how much deflection we're going to get. The amount of bullet deflection, which is how far away from your center the bullet's going to fly, is equal to 24 pi times by your muzzle velocity and your time of flight, and delta divided by your twist rate. So this says that the faster we go, the more deflection we get. The longer it takes to get to the target, the more deflection we get. And the faster your twist rate, the more deflection you get. But this delta is referencing the offset from the center of the bullet to the center of gravity in inches. Now you could take your bullet apart like we did here and measure the jacket thickness, but then you can't shoot your bullet anymore. And even if you could, sometimes you get little voids or other imperfections in the lead jacket, or the bullet gets engraved asymmetrically, which is when the rifling engraves your bullet. It may not do it evenly. And so even if you could measure it, it's essentially impossible to predict what this variable is going to be. But even if you could clone every bullet, and let's say this offset was exactly the same at 1/10,000th of an inch on every single bullet, you still wouldn't be able to put every bullet through the same hole, because remember the top, they come out at a random orientation when they come out of the barrel. And so even if they were all identical, they still wouldn't all go through the same hole. Even if you can't calculate where every single bullet is going to go, the point is you need to minimize all of your variables. One of your biggest variables is bullet imbalance. If you want to minimize that variable, you shoot good bullets. Like these Burger hybrids, I love Burger hybrids. Senior Match King's also a top-notch bullet. The reason I spend the extra money on high-quality bullets is because it makes a difference on target. All right, if you made it this far, thank you for watching. We've had fun making this. We hope you enjoyed watching it. This is a multi-part series, so be sure to subscribe so that you can catch our future episodes, and we'll see you next time.